This week we chose to go with our Belzona Super Wrap 2, which is our ASME engineered composite. This is it right here. It's a carbon fiber fiberglass hybrid reinforcement, and we embed epoxy resin into it, and then it turns into a hard composite that can be used for a variety of repairs. So going into it, we're going to give you a high-level overview of ASME Article 401, which is the article we use to design these wraps. We'll go through a standard process of repair, and then we'll go into some case history showing you how we use them. So starting out, it's the standard we use is ASME Article 401, non-metallic composite repair systems for high-risk applications. Defining high risk, because there's also a standard for low risk, we chose to go with the high risk so that we have more options for repairs. Because using this standard, we can repair any line or equipment that's, as you can see here, pressures above 150 psi, temperatures above 120 or less than 0. And also we have this leaking diameter relationship, which we can match that as well. So it has a lot of different types of options that you can use it for, a lot of different equipment and repair areas that you might find useful within your facility. So how do you get your system to be able to repair these scenarios? Well, the first step is developing your product. So Belzona Corporate spent years researching the best possible combination of carbon fiber and fiberglass. The actual reinforcement is designed in a way that gives it, certain strength in certain directions, which makes it better for pressure equipment. And the epoxies were designed to be able to have high temperature resistance and chemical resistance. And as per the standard, you have to do pre-qualification testing for a lot of different testing, such as temperature resistance, strain and stiffness testing. That's where we're going to get our elasticity, module of elasticity, Poisson's ratio. We do a lot of pressure retention testing. So if you look at these pictures on the right, we do pressure testing to failure for both thin and through wall piping. So we have our pressure spools. They'll have a hole in it, and we'll pressure them up until the wrap fails. We also do an 1,000-hour pressure test at a certain pressure to give it our long-term strength. We're going to do our ISO chemical resistance testing, which is a year-long immersion chemical resistance testing. And then there's a whole bunch of other types of testing that might come into play at some points. We have cathodic disbondment, impact testing, even fire resistance testing. And all of these tests are used to gather variables. And with those variables, our strength variables, our pressure retention variables, our temperature and chemical resistance variables, we're able to design a super wrap system to fit whatever equipment we're trying to repair. So going through the design, what we do is we use all those variables from the testing, we plug them into the equations, and we calculate how thick our repair has to be to have enough strength to withstand the hoop and axial stresses of the system. If your piping or equipment has a leak, we can also calculate how thick our repair has to be to retain that leak. So how much energy we can withstand from a leak coming out. All of the design is based on a defective area. So if you have a pipe with a certain thin wall or corrosion, we're going to use that area as our base substrate, and we're going to design how thick we need to be to bring that defective area back to where it was originally when it was installed. So basically, we're just bringing the acid back to design pressure rating. As far as applicability, we can use this repair on coated piping, tanks, and pressure vessels. We can do internal or external corrosion, thin and through wall defects. And whenever designing, it's really important, and we'll discuss this later, to understand the damage source, understand what's going on. You really have to have all the data, such as pressure, chemicals, temperature, and then pipe geometry and dimensions. So play this video here. It's really important to get the design correct, to have the best possible repair system as far as R&D. But one of the most important things is really installing it correctly. So there is certain ways to install this, certain procedures you have to follow. So as per ASME, whoever installs this, for it to be a compliant repair, they have to go through a regulated training process. So we offer training here in our shop, and we also can go on the road to do trainings. And we're going to give a full training, usually ranges from a half day to a full day. We're going to cover, standard basics on the standard, so they understand what needs to be done per each repair. And we're also going to do a lot of different geometry. So for instance, here we're wrapping a nozzle. We'll do T's, we'll do patches, straight pipes, bends, anything they can encounter in the field that might be a little more than just a straight run pipe. So we also cover, how to inspect the wrap once you're done, and also very important QA/QC documentation, and doing a quality repair, which is all part of the standard. So as you can see here, they wrap the nozzle. It's not very difficult, but there are little tricks that are going to make it a lot easier and a lot better repair. So that's kind of just a high-level overview. So you have to pre-qualify your system, you have to design it, and then you also have to train the installers. So going through a full process of a repair, the first thing is you need to have a system that's pre-qualified. We've already done that at Belzona. The next step is, if you have an asset that needs a repair, we can get one of our guys or work with you to get a full survey report. So within that survey report, we're going to get all the operating conditions that we need, the asset dimensions, all the stuff we need to create a design package. Once we have all that information, we'll create a design package. Normally it's, same day. If we need some more information, maybe we'll be back the next day, but we'll come up with a full design package, procedure, repair outputs, everything you need to install that system. The next step would be the implementation. So this is where you would need some trained installers to install the system. Now, one thing we've done with a lot of clients is, if you have in-house contractors, get a couple of them trained, so you always have someone on site that's trained, because a lot of times these repairs can come at you quick. You might find something that you didn't think you were going to find. You can send that over to us. Same day we have repair outputs. Next day you have product, and you're fixing it, fast. It's a boom boom operation. That's what we've done with a lot of our clients through our planned reaction process. So once you've installed the wrap, you're going to fill out your QA/QC documentation throughout the process. That documentation gets sent back to us so that we can review it. We also review it with the Belzona Inc., our manufacturer, and they provide us with a compliance letter that states that everything was done as per the standard. And then furthermore, once you're done with all those steps, you've repaired your system, you can inspect it down the line. The inspection technique is going to really depend on the type of defect. If you're having like an external corrosion case, once you put on the wrap, you've stopped the corrosion source. So really just a visual inspection to make sure it's still intact, it's not leaking, that's going to be suitable. If you have more of an internal corrosion case, then we would recommend maybe a yearly or every 2 years inspection via X-ray or low frequency DRS, which is a low frequency UT, just to see if that defect underneath is going beyond our wrap. And also when we design, we take a lot of that into consideration. If it is an internal corrosion case, we might extend our wrap a little further. If it's one area that has bad, maybe like an elbow that's getting some erosion, we'll go a little further so that we can grab some good substrate. We can also design to assume that there's not going to be any metal in 2 years, or we can design for a corrosion rate that in 3 years, this metal is going to be this thin, so let's design for that. So there's a lot of different options we can do as far as design to make this a long-term repair. So going into some case histories, this is your fundamental super wrap application. You have a hole in the pipe, straight run. This is a 20-inch pipe with a 1/2-inch hole operating at 700 PSI. So we'll use that data together with our testing data to figure out, hey, we need 4 wraps to withstand this pressure. So we send the design over, the guys in the field install it as per the design, and you no longer have a hole. So that's the basics of it. This was installed in 2016 and is still running today. At times though, and this is why we like to do the training And not only the training, but it's good to, once we work with our clients and we've done a couple repairs, and maybe even have a couple conversations or meetings with the inspection team, they'll understand what we need to make a design so that the process is just faster. So in this scenario, we had some seepage locations around the manway. They did not want to prep around here because if there was, if you put some mechanical prep here, you could worsen the issues. So we communicated that. They gave us a full grid of what we needed to repair. They gave us dimensions, and we came up with a full procedure. So our procedure was, first we're going to apply our 1221, which is a surface tolerant quick cure material over the seepage locations. Then we're going to rebuild this defective area because they did not want to touch it. They did not want to put any mechanical preparation on it to avoid having any issues. Once this product sets up, now we have a better safety factor for doing a good prep. So what we did was we did not prep this area. We put a surface tolerant solution that becomes the defect. And then we extend our surface preparation beyond the defect. So we always want to have some good surface prep beyond the defect. These repairs work via, a good adhesion to the substrate. So you need to be able to stick to somewhere beyond the defect so you can kind of encase the defect. So as you can see here on the right, we gave them a full procedure, the diagrams. And then once they do all the prep work, that's when you go ahead and install your super app. So everything here was designed per the standard. The length that we went beyond the defect was determined with ASME. The number of wraps was determined with ASME. So everything's done as per standard. These installers understand that. So when they get a design package, they go to the page that they need to go to, and they see, hey, I need to do 6 layers. I need to go, 5 inches this way, 5 inches that way. So it's a very precise and custom repair per each application. This is another patch repair, and the reason we have a million applications of a straight run pipe wrap, but I wanted to show you kind of the versatility. So you can do patchwork on tanks. You don't always have to do a wrap. This was a crude oil storage with a leaking defect. We were able to stop the defect with the tank in service, and then we used a vapor blasting technique, which is a non-hot work technique to prep, and we applied our Belzona Super App 2 patch. This is another kind of, I would say different application, but we've done this quite a bit too. So this is a line that was by a cooling tower. So the top had some real bad corrosion. And this is one of those scenarios. Again, they don't want to put too much mechanical prep over this, defective area. So we defined a defective area where we're not going to prep. We're just going to, maybe hand tool prep just around the pits, nothing too heavy. We don't want to cause any, leaks in the field. We're going to cover it with a surface tolerant, paste grade rebuilding product, let that set up. Once that sets up, now we can prep knowing that we're not going to damage anything that we don't want to damage, and we can extend our wrap beyond the defective area as much as we can. So in this scenario, we kind of did about 80% of the circumference of the pipe. Like I said, you don't always have to go completely around the pipe. It's gonna reinforce whatever it sticks to, and it's also going to provide corrosion protection. Now you're not going to have any issues of cooling water, tower mist causing corrosion. Another leaking nozzle. So this is one that we get a lot, and this is one of the reasons why we added the nozzle procedure to our training, was because it was happening so much. We have our technique to do it, and it's pretty simple, but if, we work at Belzona, we think about Belzona night and day, so we have our methods. So we like to teach those during the training to make it easy on the installers and to get quality repairs. So it was leaking at the nozzle. We designed a system. Like I said before, the key is to you always want to have good prep, and you always want to go past the defect in both directions. So if you're ever leaking on a weld at a nozzle, we're going to have to most likely go onto the tank or pressure vessel, whatever the nozzle is attached to, and go down the nozzle as well. So that's why we went in both directions. You have to have some some surface adhesion beyond your defect to withstand, to hold in all the leaking pressure and all that. So we have our method, and it's not too bad. Training's, that's where we teach our training. Like I said, the nozzles keep coming. So we get about, these come pretty frequently. This was a recent repair. They had 2 nozzles coming out of a pipe here. This was a scenario where they did a UT or X-ray inspection and found that they were having a more severe case of erosion corrosion than they thought. It wasn't a through-wall defect yet, but they were so thin in certain areas that they were, it was a kind of fast one where we had to move fast. This client was part of our planned reaction program. They had 2 sets of workers, contractors out there that were trained. So they always had someone at the site trained. So we were able to get a design, kind of same day. And, it was on Friday. Then Monday, they were able to install this wrap and have their safety back online, they were pretty low here. And then once again, especially for a procedure like this, it's really helpful for the installers. We always try to make a nice procedure sketch to show them a step-by-step. So this was the final step, but we'll give them a full procedure, what to prep, what to rebuild, what to do, how many wraps, how far to go, and we try to draw it out if we do get some schematics. So this was kind of the end repair on the top. So they went down the nozzle and onto the pipe. And like I said earlier, the typical repair is going to be on piping. That's about 70%, I would say, of the repairs are on piping, but we do a lot of super wrap on tanks. And, every now and then we will do a pressure vessel, whether it's a patch or in this case, a full circumferential wrap. It can work on different types of equipment. In this case, this pressure vessel had a CUI issue. A lot of these areas were, getting close to that T-min. So they were pretty worried about that. And obviously, one method would be, coat this and stop your corrosion, but then you're not really reinforcing those weak areas. With the super wrap technique, not only are you giving it a corrosion resistance system, you're also reinforcing those low areas. So you're kind of killing 2 birds with 1 stone. This was done in 2016, and we went and actually inspected it last year, and it was in perfect condition. This pressure vessel has been in operation ever since. The repair was done while the pressure vessel was in operation. So they haven't had to stop, and during the next turnaround, they'll see what they do, but it's working so well that there's, it might be extended. So once they can do some visual inspection on the inside and determine what to do with that. So thanks guys for joining in. These are the bi-weekly meetings, just meant to be a quick overview of what we can do. And the ASME engineered repair is definitely one of my favorites. That's kind of one of my specialties here, and it's helped a lot of our clients. And if you guys are interested, I think the planned reaction program is really where you can make this worth your while, because it's just the efficiency of repair is just very, very beneficial to our clients from what we've seen. So just, if you have any questions now, you can unmute yourself and ask. And if you have any thoughts or questions, anything else you want comments, you can throw them out now.
Hey, Alex, this is Barry. Hey. We got some guys here from Invista and with Monday. So guys, feel free to speak up if there's anything that came up here specific to the project you're going to be starting here in the next week or so.
Yeah, and if you do want the continuing education credit, just send a direct message with your email and full name, and we'll get you a certificate for 1 hour. Hope you guys learned a good deal here, just a high-level overview.
Hey Alex, this is Dan. One quick question. How do you set your design life for these repairs?
So that's going to be based on the source of corrosion. If it's an external corrosion case, Normally it's 20-year repair, depending on if there was a through wall hole or not. Just because once you put on that repair, there's no more corrosion, and the repairs can be designed anywhere from 2 to 20 years is the design life. We also can design based on no substrate. That's what really takes it to that 20 years. In that case, we're designing a super wrap thick enough to withstand all the pressure without any contribution from the steel. That's when we know that we're good, even if the steel corrodes away. For internal corrosion cases, we normally go the 2 to 5 years with inspection intervals, and then after the inspection we can extend it. So if we designed for a certain thickness and then we inspect it in 2 years and the design is not applicable anymore, then we might have to redesign, or we might have to add a couple of layers or make the repair go a little further. So it all depends on the scenario.
Gotcha. Another question is, can you re-rate a repair of one of these wrap repairs? Say the MAP for the line goes up 100 pounds pressure. Is that something that you can do?
Yeah, we can definitely do that. I mean, are you saying like once it's in service, you raise
Correct.
the pressure? Yeah, so I mean, I'll tell you for the most part, so the minimum number of wraps that we're gonna do is 2, and the minimum for like a through wall is 3. And for the most part, you're actually gonna need less than that. So we're giving it some extra safety factors. So if you had like 100 psi, we can recheck the design and see if we're still within that. I just had one today that we sent the design yesterday, and then they sent it back to us that they added 100 psi actually, and the design didn't change, so it was the same design. So if it does change to where we need one more wrap, we can just come there and add one more wrap. That's what kind of could happen if you're adding 200 pounds to the line or something like that. You might have to add one wrap, but we can redesign it and see what we need to do.
Okay. Thank you.
No problem. Yeah, any more questions? And if you guys have any, if you want to check out our website, trustbhi.com. And we have a lot of different examples, pictures. Bellzonehouston.com has a little more product. Yeah, thanks guys for coming.